Greetings, this is M Squared. We're going to solve some linear systems using the method of graphing. There's 3 different methods, but for this one we're going to use graphing. Remember, linear means line, so we're actually finding out where 2 lines intersect. That's what the solution would be the point or points where they intersect. So real quick, let's remember what can happen when I have 2 lines. They can intersect once and have one solution. They can be the same line, so they're kind of on top of each other, so they have an infinite amount of solutions, or they can be parallel and not intersect at all, which means they have no solutions. So sometimes the book will ask you, are they consistent, inconsistent, dependent, or independent? If they intersect once, they have one solution, their equations have different slopes, they're consistent and independent. If they are the same exact line, they'll have the same slope and y-intercept. They're and an infinite amount of solutions, that's considered consistent and dependent. And if they're parallel, they have no solutions, and that's called inconsistent. Their slopes would be the same, but they'd have different y-intercepts. So keep that in mind. You might want to jot that down or pause it and print that page off. But I'll refer to this again, but I won't show you that picture again as we go in to find our solutions. So the easiest way to graph a line is to get it into slope-intercept form, which means you have y alone. You might remember y equals mx plus b. So this one has y alone. I know my slope is 1. This one right here doesn't have y alone, so to get y alone, I minus x from both sides, and I get y equals negative x plus 2. Well, the slope here is negative 1. So right away, I know my slopes are different, and so it's going to have one solution, and it's called consistent and independent. It's nice to know before I start graphing it, because if I happen to graph something wrong and I get them to where they're the same line or they're parallel, then I would know that I did that wrong. So I'll graph the first one. The y-intercept is negative 4. The slope is 1, which means I go up 1 over 1. So there's that line. This line right here has a y-intercept of 2 and a slope of negative 1. So do you notice where they intersect? They intersect right here, which if we want to write that down. Remember, the goal is to find where they intersect, so that's our answer. So 1, 2, 3, 1. So I went right 3 and down 1. Now, if you want to check to see if this solution is actually correct, you can also put it back up into the original equation. If x is 3, does 3 minus 4 equal negative 1? Yes, it does. Check to see if it works in this one as well. Does 3 plus a negative 1 equal 2? Yes, it does. So I know that I'm 100% sure I'm right. And remember, that's called consistent and independent if they are asking about that. Okay, for this one's already in slope-intercept form, so I know my slope is negative 1. This one right here, I need to get y alone so I can graph it easier. So I'm going to move that over. So I get y equals negative 4x minus 2. So here my slope is negative 4. So I'll graph this one first. I go down 2. My slope is negative 4. So I can either go 1, 2, 3, 4 down and right 1, or I could go up 4 and over 1. And now I'm going to graph this one. There, my y-intercept is negative 5, and my slope is negative 1. And we can kind of see where they're going to intersect there. And so we know it's 1 over and 6 down. So our answer is 1, negative 6. And since it had one solution, again, that's consistent and independent. And if I wanted to make sure, 100% sure that I'm right, I can plug those back in. So a negative 1 minus 5 is negative 6, so that one worked. And over here, 4 times 1 is 4, plus a negative 6. Negative 6 plus 4 is negative 2. So if you want some more challenging ones, you could look at the next lesson. Good luck. M Squared signing out.